Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are beginning a new topic today, sets. What are the objectives that we look forward to achieving at the end of this topic? At the end of this topic, you should be able to list the members of a set. You should be able to identify and understand the properties of operations on sets. You should be able to identify the various regions of a Venn diagram. And you should be able to solve practical problems using a Venn diagram. Now, let's learn more about sets. A set is a well-defined collection of objects of the same kind. Now you can see from here that I changed the color of well-defined to red, which means that for a collection to qualify as a set, it has to be well-defined. If I ask you to give me a list of brave men, your list is going to be different from the list that I will produce, because what qualifies as brave for you will be different from mine. And we also do not know the same number of people. So such a collection cannot qualify as a set. But if I ask you to give me the list of odd numbers less than 20, that is well defined. Yours will be the same as mine. So that qualifies as a set. Sets are denoted by capital letters and its components are enclosed in a curly bracket. Now here is an example. Allow me to bring my pointer so that I can show you. Now we can see from here that this is the set A and it's being denoted by a capital letter. And the members of set A are enclosed in curly brackets as shown here. This is also the set F and this is the set V. They are all enclosed in curly brackets. The components of a set are called its members or elements of the set. So for example, for set A, the components, that is 1, 2, 3, 4, and 5, are called the members or elements of set A. I hope that is clear. It's the same for set F and set V here. Set F has the elements A, C, and N, and set V has the elements 7, 8, and 9. So these are called the components, these are called the members or elements of the set. The number of elements or members of a set is known as its cardinality. Now when we come to set A, we can see that there are 5 members, that is 1, 2, 3, 4, and 5. So we say that the cardinality of set A is 5. When you come to set V, we can see that there are 3 members, A, C, and N. So the cardinality of set F is 3. And the cardinality of set V is also 3 because there are just 3 members. I hope that's understandable. Now let's learn more about sets. We move on to types of sets. We will consider the first type called a finite set. A finite set is a set whose last member can be found. So an example is this. We have set A with the members 1, 3, and 5, and set D with the members 3, 5, 7, and 8. In each case, we can find the last member. In set A, the last member is 5, and in set D, the last member is 8. So we see that these sets are finite sets. On the other hand, we have infinite sets, a set whose last member cannot be found. And these are examples, set F and set B. Now we can see from here that set F has the members 1, 2, and 3, and it continues. And set B also has the members 2, 4, 6, 8, and the list also continues. Now we can see some dots after each of the members. What this means is that the list continues to infinity, and because we can't list all of them, we bring the dots to show you how it continues. The members that are listed for each set gives you an idea of how to continue. For example, in set F, the first 3 members are 1, 2, and 3. So it gives you an idea that the following members will be 4, 5, 6 upwards. The same thing applies to set B. We have 2, 4, 6, 8, and 10. So logically, it follows as 10, 12, 14, and the list continues onwards. Let's consider another type of set, a null or an empty set. A set which has no member, just as the name denotes. An empty set is a set which is empty. Empty set is represented by either this or that. So let's take, for example, set H has no member. Set H is represented by H equal to an empty curly bracket, or set H is equal to this symbol. Now remember that if you have this, let's say set H being equal to 0, this is not an empty set. It means that set H contains a member and that member is 0. If you want a null or empty set, it's either this or that. I hope that's understandable. I'm going to clean this so that we can continue. Okay. We move on to another one called the unit set. A set which has only one member is called a unit set. So for example, set M has just one member, 2. Set E has just one member, 12. So both set M and set E are called unit sets. We move on to another called the universal set. It is the set of all the objects under consideration, and it is represented by these symbols. I'm going to bring the pointer back. So it's represented by these symbols, either this or that. Usually we use the U because it is easy to write. Now what the universal set means is this. It's sometimes also called the mother set. It is the set of all the objects under consideration. Let's say that we ask you to list prime numbers. We know that the set of prime numbers belongs to a bigger set, which is the set of numbers. So the set of prime numbers belonging to that bigger set, the bigger set is called the universal set. Another example is this. Let's say we tell you to list a set of red flowers. You can mention a lot of red flowers, right? But we know that red flowers belong to a bigger set called flowers. So in this case, the bigger set, which is the set of flowers, becomes the universal set. Whenever a set is being listed, we assume that it belongs to a bigger set, and that bigger set is known as the universal set. We are going to take a lot of examples so you get this very well. We move on to another one called the equivalent sets. Sets are said to be equivalent if they have the same number of members or they have the same cardinality. Now here is an example. We can see that set S has the members 5 and 6. Set T has the members 14 and 15. Now the cardinality of set S is 2 and the cardinality of set T is also 2. So we say that set S and set T are equivalent sets. Another example is also this. Set G has the members 1, 7, 8, and 9. Set K has the members 7, 9, 11, and 13. Now we see that the cardinality of this set is G, and the cardinality of set G is 4, and the cardinality of set K is also 4. So we say that set K and set G are equivalent sets. We have another one called equal sets. They are sets with the same members. So what it means is that the number of the members in one set is the same as the members in the other, and those sets are called equal sets. An example is this. Set N has the members 3, 7, 9. Set Y has the members 3, 7, 8, and set Y also has the members 3, 7, 8. So we say that set N and set Y are equal sets. We can also see from here that set P and set W are also equal sets because they have the same members. Now you can see clearly that all equal sets are equivalent sets because they have the same members and they also have the same cardinality. So all equal sets are equivalent sets. Disjoint sets. Two sets are said to be disjoint if no member of set A belongs to set B. This is what it means. I'm going to give you an example. You can see from here that set T has the members 14 and 15, and set G has the members 1, 7, 8, and 9. Now, no member in set T belongs to set G, and no member in set G also belongs to set T. So we say that set T and set G are disjoint sets. It's the same with set W, set S, and set W. They have no member in common, so they are said to be disjoint sets. We move on to another very, very important thing: subsets and supersets. What are they? If all the members of set A can be found in set B, then set A is said to be a subset of set B, and set B is a superset of set A. Let's use an example to explain this. Let's say that we have set A with the members 1, 2, 3, and set B with the members 1, 2, 3, 4, 5, and 6. Now we can see clearly that the members of set A, which are 1, 2, 3, can all be found in set B. So we say that set A is a subset of set B, or set A belongs to set B, and is written as this: set A is a subset of set B. In this case, set B becomes the bigger set from which set A was derived. So set B is a superset of set A, and is also written as this. We move on to the set of numbers. We are going to consider a lot of numbers. So we are going to see some set of numbers. The first one is the set of natural numbers, and begins with 1, 2, 3 upwards. So this is an example of an infinite set, so you can continue. Another one is the set of whole numbers. It's similar to the set of natural numbers. The set of whole numbers rather begins with a 0 and it continues. 0, 1, 2, 3, 4, 5, and it continues from there. We move on to the set of odd numbers. We already know odd numbers. Numbers that result in a fraction when you divide them by 2. So examples have been given here: 1, 3, 5, 7, 9, 11, and the list continues on and on. The set of even numbers. Numbers that gives you whole numbers when you divide them by 2. 2, 4, 6, 8, 10, and the list also continue. Move on to the set of prime numbers. Prime numbers are numbers with only 2 factors, 1 and the number itself. So the set of prime numbers are also given here: 2, 3, 5, 7, 11, and 13. They are similar to the set of odd numbers, but do not confuse them. For example, 9 is an odd number but not a prime number, because 9 has 3 factors. 15 is also an odd number but not a prime number, because it has more than 2 factors. We go to the set of integers. Integers are positive and negative whole numbers. So positive and negative whole numbers, which means that it begins from negative infinity to positive infinity. Remember, they are whole numbers, positive and negative whole numbers. Thank you for watching this video. Catch you in the next video where I will teach you how to list the members of a set. We are also going to consider operations on sets. Bye bye.